All right, good afternoon, mathematicians. In this video, I'm going to be walking you through the study guide that is in your workbooks, your Unit 6 workbooks, okay? So that's going to be on pages 96 through 98, okay? Now, I have to remind you guys, this was not assigned as homework, okay? So I will not be checking this later on during class, okay? What I will be checking though is pages 84 and 89. Those were assigned as homework, okay? But the study guide is solely for studying purposes, okay? Your test is going to look pretty similar to this study guide here, and with that, I think let's just dive straight into it, okay? All right, so first and foremost, you should always read the directions, okay? Because I can't tell you how many times I have kids who don't follow directions and then they lose points and then they're sad. Okay, so follow the directions. So it says show all work to sufficiently prove your answer is correct. Writing and evaluating formulas is the best method. Okay, so that just means we need to show our work. We're going to be using formulas here that we've came up with before. Okay, now we're going to read this box here. Use the following information to answer exercises 1 through 3. Okay, and again, remember to show your work. So a movie theater sells 2 sizes of popcorn. We have popcorn T and popcorn R. One box has the shape of a triangular prism, hence popcorn T. The other box has the shape of a rectangular prism, popcorn R. The boxes do have tops. That is important. The boxes do have tops. That will affect our surface area here. Okay, I'm going to split this down the middle so that way I have some room to do the triangle and then the rectangle. Okay, so I'm going to do my work for popcorn T here, popcorn T, and then popcorn R on the other side. Okay, and we are looking for how many square inches of cardboard surface are needed to make each box. So hey, that looks like they're giving us a hint. We are trying to find the surface area. All right, let's go ahead and do this. So best way to find surface area, and this is our basic definition of what surface area is. So remember that surface area, you just find the area of each face or each side of your prism, okay? And you are going to add them all together. Now the first thing we should ask ourselves, well, how many faces are there? Well, I see 1, I see 2, I see 3 on top, there's 4 behind over here, and then 1 on the bottom as well. 5. So I see 5 sides total. So I'm going to be adding 5 different things. Okay. So the first thing, well, my base of this prism is a triangle. Okay, and the dimensions that are going to help me find the area of this triangle are actually going to be 10 and 8. Okay. You will notice that whenever you're given a right triangle, so a triangle like this here, the dimensions that are on either side of that little, of the little right angle mark, you know, that little square that you see in the corner? Yeah, the 2 dimensions that are on either side of that are going to be the dimensions you need to find the area, okay? So the area of this triangle is going to be 10. You're going to multiply it by 8. Okay, and then you're going to divide it by 2 because it is a triangle. So 10 times 8 is 80, and then 80 divided by 2 is 40. Okay, so boom, there we go. I have my first shape. Is there another triangle in this prism in the popcorn box? Why, yes, there is. There's a top and there is a bottom triangle. So what we're going to do is we're going to add 2 40s. So I have 40 plus 40. Okay, all right. Let's take a look at what I need next. So it looks like I'm going to highlight this in blue. I have a rectangle here. Okay, so I have that rectangle. It looks like the dimensions of that rectangle are 5 by 10. 5 by 10. So therefore, this rectangle here is going to be 50. The area of this rectangle, I'm sorry. So I'm going to add that to my little expression down here. Okay, let's double check. I'm going to switch colors. Let's double check this purple side over here. What are the dimensions of that side? Well, the purple rectangle, it's still going to have I guess a height or a width of 5 here. And then the length there is going to actually be 8. So now I have an 8 by 5 rectangle, and therefore the area is 40. So I'm going to add another 40 here into my expression. And let's see, I have one more rectangle, it looks like. I'm going to do that in green. That's going to be the rectangle in the very back. And you might be wondering, Mr. RG, I don't have all the dimensions that I need. And I will say, I agree with you, we're missing something. So, in fact, what I'll have us do is, I'll have us make this side 11 inches, okay? So now we have a rectangle that is 5 by 11 inches. So therefore, this rectangle is 55, has an area of 55. Okay, and that is the last thing we are going to be adding. Notice how I have 1, 2, 3, 4, and 5. I have 5 sides to my box here, therefore, my final answer, well, let's go ahead and see this. 120 plus 50 is 170. I think that's going to be 225, right? 40 plus 40 is 80 plus 40 plus another 40, that's 120. 120 plus 50 is 170, yeah. And then plus 55. There's 12. Yeah, we're at 225. So the surface area of our popcorn tea is going to be 225 square inches. Okay, now let's go ahead and do the same thing except for now popcorn R. Okay, so popcorn R. Again, you can definitely split this into shapes just like we did the triangular prism. So I'm actually just going to do that because I think that helps people the most. Okay, so I'm going to be looking at this rectangle right here. Okay, well, what are the dimensions of that first rectangle? Well, I see a 9 by 6, and therefore it's 54. Okay, now you need to ask yourself, well, how many faces have an area of 54? Hopefully you said 2. There's one on the front and one on the back. So in my little expression down here, I'm going to add 54 plus 54. And let's go ahead and switch colors here. Okay. Actually, I'm going to highlight the rectangle in the back. That's exactly the same, okay, as the one that we just did. And there we go. So we have 2 of those. 54. Those both red rectangles are 54. Have an area of 54. Okay. Now let's go ahead and look at the bottom here. I'm working in pink now. Hopefully it's not too similar. Okay, so in the pink rectangle, what are my dimensions? Well, it looks like I have a 2 by 6 rectangle. So the area of that rectangle is going to be 12. 6 times 2 is 12. Do I have another one of these faces? Why, yes I do. Going straight up to the top, the very top of the box is the same rectangle. So it looks like I'm going to be adding 12 twice. There we go. Now I have one more set of rectangles, and I will do this in, let's see, what color have I not used? Let's go to my fancier colors. I'm going to use this light purple here. So it looks like I haven't used these rectangles on either side. Okay, and again, there are 2 of them. And we know this is a closed box, right? So therefore we're adding 2 sides, or we're adding the areas of 2 sides. So let's see, my dimensions of this rectangle, and this is a skinny rectangle standing up like that, it's going to be a 2 by 9, so my area is going to be 18. So I'm going to be adding 18 twice. Once you add up all of these numbers, you will have your surface area. I know 12 plus 18 is 30, so let's say that's 30, and then that's another 30. 30 plus 30 is 60. 60 plus 54, or I could do 54 plus 54, that's 108. 108 plus 60 is 168. Yeah, my work might be a little confusing here. Sorry. 100, so this goes up here, so that's 108 plus 60, and that's 168 square inches. And there we go. So it looks like it's going to take less cardboard to make the rectangular or popcorn R. which is interesting. But then again, the triangular prism, popcorn T, had larger dimensions. So, very cool. Let's keep going on. How many cubic inches of popcorn will fit in each box if the top of the popcorn is level with the top of the box? Okay, so I'm going to make another line down the middle here. So again, we're dealing with popcorn T of my triangular, and then popcorn R. Excellent. All right, so we know that volume, right? This is asking us, if this doesn't give it away, take a look. Cubic inches. Whenever you see cubic inches, immediately your brain should go to volume, okay? So we use this formula for volume, right? Capital B times H, where capital B stands for the area of your base. Now, in the triangular prism, our base just so happens to be a triangle, right? We're going to save ourselves some time here because we actually already found the area of the triangle here. Take a look at that, right? Work smarter, not harder. So we're actually just going to take this, right? So we know that volume is equal to the area of the triangle, which is 40. But now we need to multiply by the height of the prism. Do not say 11. Don't say 11. Your height in this case is going to be 5. Right? So your popcorn box is laying flat, so therefore the height is going to be that 5 inches. Okay? So we have a volume 40 times 5, so our volume is equal to 200 cubic inches. Boom, there we go. Let's try the next one. Popcorn R. You guys are very comfortable with this. You just multiply the 3 dimensions that you see. So most of you would say 9 times 6 times 2, right? Doing a little bit of mental math here. 54 times 2, well, that's 108 cubic inches. And there we go. How'd we do? Hopefully okay. Volume, I think volume is definitely much more simple than surface area. Surface area, there's just a lot of parts to it, and you have to keep track of it, but volume, not so much. Okay, let's see. Let's keep moving on. Number 3, it says, suppose the theater decides to sell a third popcorn size, the family size box. The family size box is a rectangular prism with a top. The scale factor from the rectangular box, popcorn R, to the family size box is 2.5. Red flags and buzzers should be going off in your head. The scale factor from the rectangular box to the family size box is 2.5. So this goes back to that lesson about compost boxes, lesson 1.4, where we had to use the scale factor to find new surface areas and new volumes, okay? So remember, we came up with a little formula here, where you take the surface area, right, SA, of your original item, okay, and you multiply it by the scale factor a certain number of times. Since we're dealing with surface area, right, we're going to square the scale factor. We're going to multiply it by the scale factor twice in order to get your new surface area. Okay, this is the formula that we came up with in class. I know there's a ton of different formulas that we came up with, but, you know, there are quite a few out there in the world. Okay, so let's go ahead and do that. So I need the surface area of popcorn R. So I'm going to take this 168, okay, I'm going to take that, and I'm going to multiply it by 2.5. That's my scale factor, right? My scale factor is 2.5. I'm going to square it. So let's see, 2.5 times 2.5 is, I believe, 6.25. Oh, let's see. Oops, that should be a 0. Yeah, 6.25. Okay, so I'm going to say 168 times 6.25. Ooh. Gonna do my work over on the side here. 168. 5 times 8 is 40. 5 times 6 is 30, plus 4, that's 34. 5 times 1 is 5, excuse me guys, sorry. 5 times 1 is 5, plus 3 is 8. 2 times 8 is 16, 12, 13. 2 times 1 is 2, that's 3. Ooh. Alright, and then 6 times 8 is 48. 6 times 6 is 36, plus 4 is 40. 6 times 1 is 6, plus 4 is 10. And then we're going to add all these together. I really hope my math is correct. 16, 20, 5, 0, 1. Please double check my math here. I have two numbers behind the decimal place here, so I'm going to move this twice. And so my answer looks like it's going to be 1,050. Let's see, and we're in square inches. Is that correct? Yes, square inches. Okay. All right, now we're going to do something similar, except with volume now. I'm going to switch colors here. So remember, our formula kind of looks the same, except only one thing is changing. So the volume of the original, if you multiply that by the scale factor a certain number of times, well, in this case, we're going to multiply it 3 times, you get your new volume. Okay, so we're going to take our volume here from popcorn R. We're going to take that 108 times 2.5 to the 3rd power. Okay, and this one I might need a calculator for. Okay, so 2.5 times, oops, that's a timer. 2.5 times 2.5 times 2.5. So this is equal to 15.625. We're going to leave the 3 decimal places in there for right now. Okay, we're not going to round or anything just yet. And now I'm going to multiply that by 108. So now I get a volume of 1,687.5 cubic inches. And there you go. So with these two problems, you need to remember these formulas here. Okay? So your surface area of your original shape times the scale factor squared will give you your new surface area. The volume of your original times your scale factor cubed will give you your new volume. Okay, so you have those two formulas to use to your advantage. Okay, on page 97, this is actually going to be like extra credit. Okay, so I'm actually going to skip these for now. I'm going to skip these for now, and I will come back to them after we've gone through page 98. Okay, I promise I'll come back to them, so don't worry. Okay. Given that one face of a cube has an area of 25 centimeters squared, show your work. So a cube, what's so special about the cube is that every side is exactly the same. So you really need to ask yourself, well, how many sides does a cube have? Well, let's take a look. Not the best cube. Here, let me try this again. I'm gonna copy this, I'm gonna paste it, and there we go. Hopefully that's more cube-like. Okay, and I'm just gonna connect my corners, and there we go. So we have somewhat of a cube. Okay, they give you the area of one side. So let's count how many sides. There's 1, there's 2, there's 3 on the top, 4 on the back side, 5 on the bottom, and 6 on the top. So it looks like we have 6 sides to this cube. So all you're going to do is you're going to take 25, and you're going to multiply it by 6, and that will give you your surface area. So let's go ahead and do this. 12, that's 15. So it looks like your surface area is going to be 150 centimeters squared. Well, now we need to find what is the volume of the cube. You know, a cube is actually made up of all squares. Hopefully you know that the squares are all the same side length, right? Every side is exactly the same. So we need to ask ourselves, well, if the area of this square is 25, what what numbers can I use to multiply together to equal 25? But they have to be the same number. So it looks like I'm going to be multiplying 5 and 5. Okay, well that's good. But now I need a third dimension. I only have 2 here. Well, surprisingly enough, well actually not surprisingly enough, that last side that you're missing is actually going to be 5 as well. Right? So every side length of a cube is exactly the same. That's what's so awesome about them. So we're going to multiply 5 times 5 times 5, so that's 25 times 5. Go ahead and do this, and we are at 125 cubic centimeters, and that is your volume. Okay, let's keep going. Number 5, it says name the 2 prisms that will result from a direct cut in the direction shown on the prism below. Okay, this might be a little difficult to see. Okay, so I'm gonna zoom in a little bit. So this blue like kind of sheet of paper that's going through my prism, that is the cut. Okay, so the question is asking me, what 2 prisms do you see on either side? Hopefully you can name this top prism that I've highlighted in red. So we'll say prism 1, or we could also say figure 1. Prism 1, well, what type of prism is that? You would say, well, I notice that the base is a triangle, so I'm going to say a triangular prism. Okay, but we need to name the one on the bottom, prism 2. I'm going to do this in purple. Well, if you take a look, what shape is this right here? What shape is that? Well, hopefully you said a trapezoid. Okay, so we can call this prism a, if you guys just say trapezoid prism, I'm okay with that, but the technical term is trapezoidal prism because the base is a trapezoid, okay? So all you're doing with this type of question is you're naming the types of prisms. So what type of prism do you see? All right, on either side of the cut, okay? Okay, let's take a look. Next question, so 5B, what new 2-dimensional shape will result on the face formed by the cut? Okay, so now we're not in the land of 3D. We're talking about just a flat, normal shape. So what new 2-dimensional shape will result? Well, you should probably ask yourself, what is the shape of the very bottom? So I'm going to highlight this in purple. The very bottom of this prism here. We'll take a look. Whatever the shape is of how do I want to say this? When you make a cut across a 3D object, whatever side is kind of parallel to this cut, that's the shape that you're going to have. So hopefully you said rectangle. So when you cut this, the 2D shape that'll appear is a rectangle. Okay, let's keep going. We're on to cylinders now. Cylinders we just finished up today if you're in my even periods. Finished up last week if you're in my odd periods, okay? So at the right are scale drawings of 2 cylinders. Cylinder 1 has a diameter of 8 and a height of 4. Cylinder 2 has a diameter of 4 and a height of 8. Ooh, be very careful. Do not get these mixed up, okay? So I would highly encourage you guys to write down the dimensions. Diameter of 8 for cylinder 1, so D is equal to 8. And a height of 4, H is equal to 4 for cylinder 1. Okay, cylinder 2 has a diameter of 4 and a height of 8. So write them down separately so you don't get confused. Okay, so now we need to find the surface area of each cylinder. Now we came up with a formula for the surface area of a cylinder. What you're going to do is you're going to find the area of the circle. Okay, so find the area of the circle, and you're going to multiply it by 2 because we have a circle on top and then we have a circle on bottom. Okay, so that's what we're going to do. The next thing that you need to find, you're going to add the quantity that is your circumference. I'm going to write over these, sorry. Next, you're going to find the circumference, and then you're going to multiply it by the height of your cylinder. Okay? Once you have these two things, then you're going to add them together. So let's go ahead and take a look at what that looks like. So, if my diameter is 8, my radius is 4, and that's what I need to find the area of the circle. And for this, I'm going to use 3.14 as pi. Okay, so let's go ahead and do this. So the formula for the area of a circle is I take my radius times itself, and then times pi. So let's see, 4 times 4 is 16. 16 times 3.14 is equal to 50.24, approximately. 50.24. Okay, so now I have that. Next, I need to find the circumference of my circle. The circumference is just my diameter times pi. So I need 8 times 3.14 times 3.14, and that is equal to approximately 25.12. Okay, but don't stop there. Remember, we need to multiply our circumference times the height of the cylinder. Okay, so I'm going to take 25.12. I'm going to multiply that by, my height is 4. So 25.12 times 4, that is equal to 100.48. Okay, so now we're almost done here. Okay, so I have 50.24, but that's only one circle, so I need to add another 50.24 plus 100.48. Or if you're fancy, you can do 2 times 50.24 plus 100.48. You will get the same answer, so don't worry. So, let's see. 50.24 times 2 is actually 100.48, so it looks like we're just adding 100.48. So it looks like our surface area is approximately 200.96, and we are in centimeters, so centimeters squared. Okay. Same thing for cylinder 2, except, our dimensions are switched now. So if our diameter is 4, our radius is therefore going to be 2. So the area of cylinder 2 is going to be 2 times 2 times pi. And let's see, what is 4 times pi? 4 times 3.14. And that is approximately 12.56 centimeters squared. Okay, next, I need to find the circumference. For my circumference, I take my diameter, which is 4, and I multiply that by pi. Well, 4 times pi we just figured out is approximately 12.56. Okay, we're going to take that. We're going to take our circumference and we're going to multiply it by the height of the cylinder, which is 8. So 12.56 times 8 is equal to approximately 100.48. Uh-oh. Something interesting is happening. 100.48 showing up quite a bit. Okay. Let's keep going. So here I'm going to add, I have the area of my circle, but I'm going to multiply it by 2, right, because I have 2 circles, plus 100.48. So let's see, what is 12.56 times 2? 12.56 times 2 is equal to 25.12 plus 100.48 for a grand total of 125.6 square centimeters. So it looks like cylinder 2 has a higher surface area. Okay, we're almost done, you guys. This question that I've kind of buried under here. Do the cylinders have the same volume? All right, so we need to find the volume of these cylinders. So remember, the volume of our cylinder, which we came up with in class, you're just going to find, you're going to take pi, multiply it by your radius, times your radius, and then times the height of your cylinder. Okay, so let's see, I should split this down the middle again. So that way I have cylinder 1 on the left side, so cylinder 1, and then cylinder 2 on the right side. All right, so I have pi times my radius, which is 4, times my radius, which is 4, and then times my height, which is also 4. So let's see what this equals. Type this in your calculators, 3.14, whoops, 3.14. I accidentally typed in 3.4. Okay, 3.14 times, well, 4 times 4 times 4 is 64, so let's go ahead and do that. 64 times 3.14. My volume is approximately 200.96 cubic centimeters, okay? And then next, let's do cylinder 2. My diameter, or my radius, I'm sorry, is 2. So what I'm going to do is going to use, whoops, what is happening? So my volume is equal to pi times 2 times 2 times 8, right, which is my height. Okay, so I'm still using the same formula here, just over on the right side now. So let's go ahead and type this in. Well, 2 times 2 is 4, 4 times 8 is 32. So now I have 32 times 3.14, and that is equal to, the volume of cylinder 2 is approximately 100.48 cubic centimeters. So I think in conclusion we can say they do not have the same volume. Okay. Excellent. We're almost done, you guys. This extra credit problem, you guys do not know how to do this yet. That's going to be something we do in 8th grade, so don't worry, okay? So now we're going to go back to page 97. Page 97, this will be more like extra credit, okay, or the extra credit that you will see. All right, so we have some equations here. Solving equations is very important. Okay, so we have, let's combine these two over here. Well, what's negative 4x minus 6x? Well, we just combine them like normal. Negative 4 minus 6 is negative 10. But we have an x attached to it. And now we have negative 20. Now, I know you're tempted to add 10x to both sides, but we're not going to do that. We're actually going to divide both sides by negative 10. So that way we can get x by itself. So negative 20 divided by negative 10 is just positive 2. And there's your answer. Let's go ahead and solve. Ooh, this one's difficult. Okay, this is going to be very involved. So I'm going to take this negative 4 and I'm going to distribute it to both of those things, to both terms inside the parentheses. So now I have something like this. I have, well, negative 4 times 1 is just negative 4, minus, I'm going to keep that minus sign, and negative 4 times 6a is going to be negative 24a. So now I have this minus a negative business, okay? 24a minus 22. So we did nothing there. All right, so I can actually change this minus a negative to plus a positive because they mean exactly the same thing. So now I have 24a minus 22 is equal to negative 4 plus 24a. Now remember, our goal is to get a by itself. So our variables need to be on one side and all of our constant numbers without variables need to be on the other side. So let's take a look. I'm gonna add 22 to both sides, right? And I can only add 22 to this 4 here, or this negative 4, I'm sorry. So now I have 24a is equal to, well, 22 plus negative 4 is, it's going to be 18, and then I have 18 plus 24a. Now remember, we need to get our variables to one side, so I'm going to subtract 24a from the right side and subtract 24a from the left side, and I have to go up here. Well, 24a minus 24a, those are just going to cancel each other out, so we're left with 0. And what is 0 equal to? 0 is equal to 18. That doesn't make any sense. That is definitely not true. Because we ended with a false statement of equality, we're going to say that there is no solution. I don't think we're going to give you guys this on the test. But that's what happens when you get something that doesn't make sense. No solution. Not all the time, but in this case, 0 does not equal 18, so therefore there's no solution here. Okay, let's keep going. These are very difficult. Okay. So drawing my line through the equal sign there, I'm going to start with any distribution that I can do. I'm going to distribute this 2 to both of those terms. So 2 times 4x is 8x. I'm going to keep the minus sign. 2 times 3 is 6. And then I have the minus 8 there. Now I can get rid of those parentheses. And then I have 4 plus 2x on the right side. Negative 6 minus 8, that's what I'm solving right now. 8x, so that's going to be negative 14, so minus 14 is equal to 4 plus 2x. Okay, again, I want to get my variables to one side and then my constants to the other side. So what I'm going to do is I'm going to subtract 2x from both sides, but I have to subtract 2x from this 8x. Okay, don't subtract it from the 14 because you can't. Okay, so this becomes 6x minus 14 is equal to 4. These cancel out. So all we're left with is 4. We're almost done. We're going to add 14 to both sides. Boop, 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 boop. And now I have to move over here to the left side. I have 6x. The minus 14 and plus 14 cancel each other out. And then 14 plus 4 is 18. Next, I'm going to divide both sides by 6. And so x is equal to 3. And there we go. Okay, last equation problem. Drawing a line down the equal sign. All right, remember, get your variables to one side. So I'm going to subtract 7x. I like subtracting or adding the smaller amount of x's because then I don't have to deal with negative x's. So I subtract 7x from both sides. I'm left with x minus 2 on the left side is equal to negative 9. I'm going to add 2 to both sides, right, getting that x by itself. So those minus 2 and plus 2 are going to cancel each other out, and I'm left with x equals, well, negative 9 plus 2 is negative 7. And that's our final answer. Okay, you guys, I don't think we're going to give you these challenging problems like this. We haven't practiced solving equations in a little while, so I don't think we're going to give you such a difficult problem. Okay, these are very involved. All right, these graphs here, so they want us to write the equation of the graph. And remember, this is the equation we write for lines, y equals mx plus b. Okay, this was in unit 5. And we have to remember that m is our slope and b is our y-intercept. Okay, if you can find those two things from the graph, then you will be good. You'll be set. So to find slope from the graph, well, remember, we're going to start at this orange point, and then we're going to go to the blue point. Well, how much do I rise? How much do I move up? Well, that's a 1. How much do I run? Actually, let me switch colors here. How much do I run? How much do I move over? Well, that's going to be 2. And remember that your slope is always, 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 always rise over run. So when we write this, our slope is going to be, well, we rose 1, so that's going to be 1, over our run, which is 2. So our slope is 1/2. Cool. Now we need to find our y-intercept. Well, remember, on a graph, our y-intercept is where the line crosses the y-axis. So I'm going to put that in red here. It looks like we are crossing through there. The coordinate of this point is 0, 0. So it looks like our y-intercept is going to be at 0, 0. Now let's go ahead and plug these into y equals mx plus b. I'm going to do that over to the left here. I also forgot to say, you guys, that slope is the same as m. Okay, so all we're going to do is we're gonna substitute these values in for m and b. So we have something that looks like this. Y equals, we have 1/2 is equal to m, so 1/2 times x, plus b, which is plus 0, right? We're looking specifically at the y coordinate there, okay? So we can simplify this so it's not as messy, 1/2 x, and that is the equation of this line. Let's try this again. I need to find the slope and I need to find the y-intercept. So taking a look here, my rise, starting at this orange dot, I have to move down 2, right? So I move down 2. That looks to be my rise. And because I'm moving down, it's going to be negative. Okay? My run is going to be positive 2 because I'm moving to the right. Okay, so moving to the right is a positive number. So I'm going to write my ratio of rise, which is negative 2, over run, which is positive 2. Well, negative 2 divided by 2 is just going to be negative 1. So that right there is my slope. Find the y-intercept. Find where the line touches the y-axis. It's going to be right there. And that point is at 0, comma, 1, 2, 3, negative 3. So this is my y-intercept. And now you can write an equation. Y equals mx plus b. And you're just going to substitute these values in for m and b. So now I have something like this. Y equals negative 1 times x plus negative 3. Now, I'll accept an answer like this, but we can actually make it a little bit easier. Or not easier, but we can actually make it look a little bit more simple and not as complicated. So what I'm going to do is I'm going to write y equals negative x, right? Because negative 1x and negative x, those are the exact same thing, okay? And instead of plus negative 3, I'm just going to say minus 3, because minus 3 is the same as plus negative 3. Isn't that cool? And now I have an easier equation like this, or a simplified equation, I should say. Simplified, not easier, simplified. Okay, last 2 questions. Woo, we're making it through. Find the measure of the missing or unknown angle. These are always fun. So we're looking for that purple angle right there, okay? And we need to use our context clues or other information that's given to us to our advantage. So the first thing that I see, the first thing that you should notice or that you should know is that the angles in a triangle, they should add up to 180 degrees. That's the first thing, okay? But now we need to figure out how are we going to get this orange angle here, because that's going to help us find this purple angle. Well, what I see is that this 120 over here, if I were to combine that with this unknown angle at v, UVT, if I were to combine those two, what would they add up to? Do you see how they create a straight line, this 120 degree and then this orange angle right here? They do create a straight line. So when you add them together, they should add up to 180 degrees. So let's go ahead and subtract 120 from 180. So it looks like the angle in question is going to be 60 degrees. So let's erase some of this. So now we have this orange angle, but we're not done. We need to find the purple angle. So we know that there's 60 degrees plus 50. So far we have 110 degrees total, and we need a max of 180. Well, we need 180 to make a triangle. So let's go ahead and subtract 180 minus 110. How much is left over? Well, hopefully you said 70, and that is your answer. So the purple angle is 70 degrees. All right, let's try this last one. So my purple angle is over here. Okay, using some of the same properties that we just used in this previous problem, we are going to use the fact that the angles of the triangle add up to 180 to our advantage, okay? angles of a triangle equal 180. So I have 25, I have 80. Okay, let me switch colors here. And now I want to find out this orange angle there. So 80 plus 25 is 105. So far I have 105 degrees. So I'm going to subtract 180 minus 105. And let's see, how much is that? That's going to be 75 degrees. So this little orange circle that I drew is now 75 degrees. And we're one step closer. Hopefully you notice that the angle that we want and this 75 degrees, when you combine the two, they create a straight line. So what we're going to do is we're going to subtract 75 from 180. And so the angle in question is going to be 105 degrees. And we are done with the study guide. I know that was a lot, but again, this is not homework. This is just good practice for you guys, okay? Anyway, happy studying, and I will see you guys